Okay, class, picking up where we left off at. We're doing problem 17a. We have 3 log b of 50 plus 24 equals 36. And we want to solve the following equations for x and give 4 decimal places where necessary. So first of all, we know we must subtract 24 on both sides. So this would give us 3 log base of b of 50 is equal to 12. Now we could divide each side by 3, and we will have log base b of 50 is equal to 4. Now, what we need to do next is this here. We should change this to an exponent so that it'll make it a little easier for us to solve. So we can make this b to the 4th power is equal to 50. Now, to get rid of the 4th power off of b, we would take the 4th root of both sides. Now, these 4th roots, the 4th root and the 4th power will simplify off, and that will leave you b, and is equal to the 4th root of 50. So we could turn on our calculator, and we can go here. We could go to the number 4, hit the math key, and then if you look here at number 5, you could press the number 5, and that gives us the 4th root, and we could type in 50 and press enter. So our final answer, it should be an approximation. So our final answer is approximately 2.6591. And that is our final answer. Now we come here to b. We'll start off by adding 1 to both sides. And we have 7 natural log of t minus 2. And that equals 5. Now we'll divide each side by 7. And we had a natural log of t minus 2 is equal to 5/7. Now, we could do the same thing that we did before. We could take the base and make this into an exponent. So we can make this e to the 5/7 is equal to t minus 2. Now remember, the base of a natural log, when it's not shown, is assumed to be e. So then we can add 2 to both sides. So we have e to the 5/7 power plus 2 is equal to t. So now we can put this in our calculator. Now if you press second and then the natural log button, you will get e to the power of. So we know our power is 5/7. We could do an open parenthesis, 5 divided by 7, and close the parenthesis. Now to get it back to the normal size, you will press the right arrow, and then we could put plus 2 and press enter. So our final answer here, of course, it'll be an approximation. So t would be approximately 4.0427 because we are supposed to round to 4 decimal places. Now we come down here. We'll first start off by subtracting 10 on both sides. So we add 2e to the 3x minus 1, and that will equal to 54. We'll divide each side by 2, and we will add e to the 3x minus 1 is equal to 27. Now we need to get rid of this e, so we can take the natural log on both sides. And the natural log and e will simplify out and leave 3x minus 1. And that will leave the natural log of 27. Now we will add 1 to both sides because remember we're solving for x here. So we add 3x is equal to the natural log of 27 plus 1. Now we will divide each side by 3. Now I would suggest we do each individual term by 3. So we have x, and it's going to be an approximation. So we can do this here. Let's clear this out. So then here, we can take the natural log of 27, close our parenthesis, and divide that by 3. And then we can add 1 divided by 3. And our final answer would be approximately 1.4319, because we're supposed to round to 4 decimal places. Now we come here to D. Now if you notice, notice we have these lead coefficients of these logs here. So we know we're going to have to change those to exponents as well. So let's do that. So this would be log base 4. Alright, come a little line again. So we would do base 4, and then we have x to the 4th, and that would be squared, minus log base 4 of 3x, parenthesis to the 3rd power, is equal to 3. So now we would take and do the exponents of the respective parentheses here. So we have log base 4 of x to the 8th minus log base 4 of 27x cubed, and that would equal 3. So now, since this is subtraction of logs with the same base, we can combine them. We have log base 4 of x to the 8th all over 27x cubed, and that will equal 3. So now we have log base 4. Now x to the 8th and x to the 3rd, when they simplify out, that will leave us x to the 5th for the numerator and 27 for our denominator. That equals 3. Now we could change this to an exponent problem. This would be 4 to the 3rd power is equal to x to the 3rd over 27. Now we know 4 to the 3rd power is 64. So 64 is equal to x to the 3rd over 27. Now we have to get rid of the 27 out of the denominator. So we'll multiply each side by 27. And so we could put that in our calculator. We could take 27 times 64. And that would give us 1,728. Now we have to get rid of this cubed off of the x. So we'll take the cube root of both sides. Now, we will put in our calculator. Let me put that here. We can take the cube root. We'll press math. And then if you see here with number 4 is the cube root. The cube root of 1,728. And press enter. That will give us exactly 12. So we add 12 is equal to x. Now, this is somewhat of a tricky problem because let's go back up here to the directions. Now, with the directions, it says give 4 decimal places where necessary. Since they ask you where necessary, since this gives you a whole number answer, you do not have to put 0.0000. So it'll just be 12 is equal to x, and it's an exact answer. So now we go here to 18. It says the tuition rates at Princeton University are shown in the table below for the academic years ending in the indicated year. So now it said let R equals F of T be the tuition rate in dollars per year at T years since 1950. Note that F is exponentially distributed. Find a function for F. Give 3 decimal places. So first of all, we're going from the year 1950 or since 1950. So we have to make our dates reflect since 1950. So we're going to do that really quick. And we know this will be our L1. So this would be 0. 10, 20, 30, 40. This would be 50, 55, and 56. So now what we would do next is this here. Write this. Okay. Now it says here they want us to find a function for f. Now we can do this in our calculator. So this is what we would do. We would go to stat, then we would press enter, and then if you have something in L1 and L2, you go to L1, you press clear and the down button. You go back up to L2 and press clear and the down button. Okay, so now we will put in the values for L1. So we have 0, enter, 10, then 20, 30, 40, 50, 55, and 56. Press the right arrow and we'll type in the tuition rate. So we have 600, 1450, 2,350, 5,585, 14,390, 25,430, and we had 29,910 and 31,450. Okay, so now we have all the values in. We'll press stat, then press the right arrow to calculate, and we're told that this is exponentially distributed. So what we would need to do is to go to the exponential regression. So we'll press enter, then we'll press enter until we get our answer. This is the exponential regression. So now we would type in the equation. We'll do f of t. We know that represents y is equal to, now it tells us to give 3 decimal places. 643.7570, and then our b would be 1.0743, and then that would be to the t. So this is our equation here. Now they tell us to find r squared. Now our r squared is listed here. If you don't have r squared, you need to go back and turn on your diagnostic. So we will have our r squared, which is 0.9923, and then state the strength of relationship. It is strong. It says, what is the base B of your model, and what does it mean in terms of this situation? So B is 1.0743, and what this means is that there is an increase of 7.43% in Princeton's tuition. Okay, and the reason why I got 7.43% is because, remember, we're supposed to take this and change it to a percent, which would be 107.43%, and then we're supposed to subtract 100% from it. So again, it'll be 107.43 minus 100, which will give us 7.43%. And that's how I got the 7.43%. So that's the annual increase, or the increase for